At 2:47 p.m. local time, a Ukrainian MiG-29 was 90 seconds into Russian airspace, carrying 2 French bombs toward a border guard post that Moscow thought was untouchable. In just 12 minutes, this pilot would either disrupt a vital supply route feeding Russian positions in Ukraine or return to the checkpoint intact, ground troops still taking fire from ammo that flowed through it. But in 6 seconds, everything would go wrong. The pilot was flying at treetop level, trying to stay invisible to Russian radar. His GPS was jammed, fuel gauge dropping toward empty, and he was navigating with a paper map taped to his knee. And if everything went perfectly, he'd have just one chance to hit the target. Then the bird hit. At 180 kilometers per hour closure rate, the Crow struck the left engine intake. The compressor blades, spinning at 13,000 RPM, shredded instantly. The engine made a grinding shriek that meant a compressor stall. The MiG lurched left, dropping toward the forest below. The pilot's training kicked in. Right rudder to compensate for asymmetric thrust. Left hand pulling back on the stick to arrest the descent. Right hand hitting the engine restart switch. The aircraft dropped from 200 meters to 180, then 160. Trees flashed by close enough to count individual branches. The restart sequence would take 30 seconds. He had maybe 10 before impact. And all of this happened at the worst possible moment. The Podlet K-1 radar, a Russian short-range, mobile, low-altitude surveillance radar designed to detect and track aircraft, drones, and cruise missiles flying as low as 100 meters above the ground at Klomovo, had been tracking something intermittent for the last 2 minutes. Small contacts appearing over ridge lines, disappearing into valleys. The operator was reaching for his radio to report when the contact vanished again, this time behind a hill just as he achieved lock. 6 seconds. That's how long his lock had lasted. 2 more seconds and he would have had a firing control solution. The operator hesitated. He could report the contact and spend the next hour filing paperwork, or he could let the next shift deal with what was probably another flock of cranes. He chose coffee. Meanwhile, the MiG's left engine coughed back to life at 140 meters altitude. The pilot felt the asymmetric thrust disappear as both turbines synchronized. But the damage was done. The engine was running rough, compressor efficiency down to 30%. And worse, his near crash had cost him time and fuel. The math was merciless. 12 minutes of reserve had become 3. Then he saw the power lines. The transmission cables weren't on his tactical map. They appeared in his windscreen like a wall, suspended 60 meters above the valley floor. At 650 kilometers per hour, he had 2 seconds to react. The pilot pulled 5 Gs instantly as he tried to maintain consciousness. The MiG rocked upward, clearing the top wire by less than 10 meters. The electromagnetic field from the cables made his instruments dance wildly for a moment. Behind him, the Podlet K-1 operator was walking to the break room, leaving his replacement to wonder about the strange radar return logged 6 minutes ago. The MiG pressed on. 1 engine damaged, fuel critical, pilot's hands shaking from the near miss. The navigation checkpoint appeared exactly where the paper map said it would, a distinctive bend in the Desna River, 10 kilometers to the release point. With 1 engine running rough and fuel for exactly 1 attempt, the pilot prepared for what military strategists call suicide, a vertical climb through 8,000 feet of hostile airspace. At 1441, the pilot reached the initial point for his attack run, 50 kilometers to target, flying at 200 meters, invisible to every radar beyond the horizon. In 45 seconds, that would change in a heartbeat. The pilot pushed the throttles forward and pulled back on the stick. The G-forces hit instantly. 6 times Earth's gravity crushed him into his seat. His G-suit inflated, squeezing his legs and abdomen. But it wasn't enough. At 3,000 meters, his vision started graying at the edges. At 5,000 meters, it became a tunnel. At 6,500 meters, he nearly lost consciousness entirely, his hand locked on the stick by muscle memory alone. The MiG-29's nose pointed almost vertical now, both engines screaming at maximum thrust. The damaged left engine was vibrating badly, threatening to tear itself apart, but the pilot couldn't reduce power. He needed every meter of altitude. On his radar warning receiver, new threats appeared every second. He had just announced himself to every air defense system in a 200-kilometer radius. Then the weapons interface crashed. The French-designed AASM bombs were connected to the Soviet-era MiG through a jury-rigged interface that Ukrainian technicians had built in a Lviv warehouse. It worked perfectly on the ground, but at 6 Gs and 7,000 meters altitude, the voltage regulator had failed. The weapons control panel showed liaison erreur, connection error in French. The bombs didn't know they were supposed to release in 20 seconds. The pilot's oxygen-starved brain struggled with the emergency procedure, left hand maintaining the climb, right hand frantically flipping switches on the armament panel. Manual override, switch to backup power, cycled the master arm. Nothing. The bomb stayed silent. That's when the Su-35 fired. 72 kilometers away, the Russian fighter had been vectoring toward the anomaly when the MiG suddenly appeared on radar, climbing like a rocket. The Su-35 pilot didn't hesitate. He locked up the target and fired an R-37M hypersonic missile. At Mach 6, it would cover the distance in 36 seconds. The Ukrainian pilot's radar warning receiver screamed, missile launch bearing 045, closing at 2 kilometers per second. But he couldn't evade, not yet. He still had to release the bombs. His left hand held the stick steady while his right found the emergency release switches, individual pickle buttons for each pylon, bypassing the digital interface entirely. 8,000 meters, release point, now or never. The pilot smashed the first pickle button. Nothing. He held it down, counting. 1 second, 2, 3. The bomb finally dropped, its rocket motor igniting after a heart-stopping delay. The second bomb's release was faster, the manual system warming up. Both AASMs fell away and immediately pitched up, their rocket motors driving them higher still. Now he could evade. The pilot rolled inverted and pulled toward the Earth in a 9G split S maneuver. A split S maneuver is an air combat maneuver where the pilot rolls the aircraft inverted and then pulls back on the stick to dive in a descending half loop, rapidly reversing direction while trading altitude for precious speed. His vision went completely black for 2 seconds. When it returned, he was diving through 4,000 meters. The R-37M still tracking. He needed chaff, needed jamming, needed something, since his jet wasn't going to outrun this missile. The chaff dispenser fired 3 bundles and jammed. The ECM pod, overtaxed from the climb, hit its thermal limit and shut down automatically. The missile bore in, now 10 kilometers and closing. The pilot had one option left, the notch maneuver. He turned perpendicular to the missile's flight path, putting it on his 3 o'clock position. The relative motion went to 0. The missile's seeker, programmed to ignore stationary objects, broke lock. The R-37M passed 100 meters behind the MiG, its proximity fuse failing to trigger. Fragments from its self-destruct peppered the fighter's tail, punching small holes in the rudder. The pilot didn't care. He was diving for the Earth, the altimeter unwinding, trying to get back to the weeds where he could hide. Behind him, 2 French bombs were climbing toward their apex, one with a rocket motor that was already beginning to sputter. The 2 AASM bombs reached their apex at 8,500 meters, their rocket motors spent, beginning the long fall toward the border guard post at Belaya Beryoska. 4 minutes of flight time through empty sky, guided by satellites they couldn't talk to, and seeking with infrared eyes that couldn't yet see. Everything had to work perfectly, but in combat, things almost never go as planned. The first bomb's rocket motor had ingested contaminated fuel, water vapor that had condensed in the Ukrainian fuel truck frozen at altitude, then turned to steam in the combustion chamber. The motor had produced 60% thrust for 20% less time than programmed. The bomb's processor, a French-designed computer the size of a wallet, ran the calculations. Current trajectory would impact 2 kilometers short of target. That's if this system didn't completely knock them off course first. The Krasuka 4 electronic warfare vehicle positioned near Bryansk activated at maximum power, flooding the GPS frequencies with 1,000 watts of precisely tuned noise. The signal from satellites 20,000 kilometers above, transmitting at 0.025 watts, vanished instantly. Both bombs lost satellite navigation simultaneously. They were now flying on inertial navigation alone, mechanical gyroscopes spinning in the dark, accumulating 2 meters of error for every second of flight. By the time they reached Belaya Berioska, they'd be 480 meters off target. For ordinary bombs, that would mean complete failure. The bombs switched seamlessly to their backup mode, INS through rough navigation, infrared for terminal guidance. The problem was now the sun. At 1449, the sun sat directly in the path of the bomb's infrared seekers. The second bomb's IR sensor activated at 3,000 meters altitude and immediately locked onto the sun. Every filter in its optical train saturated. The computer registered a heat source of 5,778 Kelvin. Clearly not a ground target. Breaking lock, searching again. Nothing but white-hot glare. For 15 seconds, the bomb flew blind. That's 4 kilometers of flight with no terminal guidance. INS error accumulating, trajectory degrading. The bomb's processor was running hot now, cycling through image processing algorithms, trying to filter out the solar interference. Edge direction, contrast enhancement, spectral analysis. Nothing worked. Meanwhile, the first bomb hit wind shear at 5,000 meters. The jet stream's edge, an 80-knot river of air moving west to east, caught the bomb's fins like a sail. The entire weapon yawed 20 degrees off course in less than a second. Its simple analog gyroscopes, never designed for such force, tumbled. The bomb was now spinning slowly, its fins at maximum deflection trying to recover stable flight. The mathematics were brutal, spinning at 2 revolutions per minute, falling at 280 meters per second. Impact in 45 seconds. The bomb's tiny processor had to solve differential equations in real time, calculating fin positions that would stop the spin without inducing a worse one. Then the S-400 battery at Klamovo detected them. 2 small contacts, falling east, radar cross-section of 0.2 square meters. The operator wasn't sure what they were. Too small for aircraft, too fast for helicopters, wrong trajectory for ballistic missiles. But standing orders were clear. When in doubt, engage. 2 48N6 missiles roared from their launchers, accelerating toward the bombs. It was a futile gesture. The missiles were designed to hit aircraft with predictable flight paths. The bombs were in ballistic freefall, their trajectory determined by gravity and drag. The S-400's computer couldn't calculate an intercept solution. The missiles flew past harmlessly, their seekers finding nothing but empty sky. At 2,000 meters altitude, salvation came. The first bomb's spin had carried it east of its intended path, away from the sun. Its IR seeker, finally clear of solar interference, activated and immediately found heat sources. 3 BTR-82A armored vehicles parked in formation, engines running hot. Lock achieved. The second bomb, still fighting the sun, took a different approach. It ignored the white-hot glare and searched for contrast patterns. The building's roof created a distinctive geometric signature, not heat, but shape. The French programmers had included this backup mode after experiences in Mali, where targets were often the same temperature as the desert. Pattern lock achieved. 2 kilometers altitude, both seekers finally locked, but the Russians still had one more trick up their sleeve. The Pantsir S-1 system you see protecting the border guard post was Russia's most modern point defense weapon, designed specifically to defeat precision-guided munitions. Its radar could track bullets. Its missiles could intercept artillery shells. Its guns could create walls of lead. But there was a problem. The bombs were coming straight down. At 8 seconds to impact, the Pantsir's radar finally locked onto the diving bombs. The operator had never seen this attack profile before. His training scenarios always showed cruise missiles approaching horizontally, helicopters popping over hills, aircraft making attack runs. These contacts were at 87 degrees elevation, nearly vertical, falling at 312 meters per second. The system's computer ran the intercept calculations and displayed a result that made no sense. Target outside engagement zone. The bombs were at 900 meters altitude. The Pantsir's 57 E-6 missiles had a minimum engagement range of 1,200 meters. They needed 1.5 seconds after launch for their proximity fuses to arm. The bombs would impact in 2.9 seconds. The math was impossible. The operator fired anyway. 4 missiles erupted from the Pantsir in a 2-second salvo, their solid rocket motors accelerating them to Mach 3 almost instantly. But physics is merciless. The missiles raced upward, their seekers trying to lock onto targets that were inside their minimum range before the motors even finished burning. At 400 meters altitude, exactly 1.5 seconds after launch, the proximity fuses armed. The bombs were already below them. The missiles self-destructed harmlessly, their fragments falling like steel rain across the compound. The operator's training took over. When missiles fail, use guns. The twin 2A38M autocannons swiveled upward, trying to track the falling bombs. Each barrel could fire 2,500 rounds per minute. 30mm shells with tungsten cores, designed to shred aircraft aluminum. The operator mashed the firing trigger, and the guns roared to life, creating a cone of fire above the compound. But the guns hit their elevation limit at 85 degrees. The bombs were at 87 degrees, still just outside the engagement envelope. The operator watched helplessly as thousands of rounds passed just behind the bombs, the slight angle meaning the difference between interception and failure. The first bomb's damaged seeker was trying to maintain lock on the BTR exhaust plumes, but the damaged gyroscopes from the earlier spin meant it was offset by 12 meters. At 50 meters altitude, it made final corrections. At 1451, impact. The 340-kilogram bomb punched through the roof at 312 meters per second. The kinetic energy alone was enough to collapse the structure. But then the shaped charge detonated. 50 kilograms of modern explosive created a jet of superheated copper moving at 8 kilometers per second. The asymmetric impact meant the jet cut sideways through the building instead of straight down. The effect was actually worse than a direct hit. The diagonal blast path took out every load-bearing wall on the north side. The building didn't collapse. It toppled sideways like a felled tree. 17 seconds later, the second bomb arrived. The damaged fin had introduced a spiral approach. The bomb corkscrewed through its final 200 meters. It impacted the vehicle bay's corner instead of the center, 8 meters off target. But 227 kilograms of steel and explosive hitting at 312 meters per second doesn't need precision. The kinetic impact ruptured every fuel tank simultaneously. The 3 BTR-82As didn't explode. They melted. The 500 liters of diesel fuel in each vehicle turned to aerosol, mixing with the air in perfect stoichiometric ratio. The shaped charge provided the ignition source. The resulting fuel-air explosion generated 4,000 degrees Celsius for exactly 1.3 seconds. Meanwhile, the MiG-29 turned west and re-entered Ukrainian lines on one good engine. Tanks nearly dry. Pilot half conscious from G-forces. Behind him, the former border guard post burned. The mission was ugly, messy, barely successful. But real war isn't a Hollywood movie. The mission was successful, and that's all that counts. Bye for now.